Welcome to part 4, Automating Parameter Bounds. Thus far, the bounds for the parameter L have been manually set for each area. If we're interested in automating the entire modeling process, then we need to find a procedure that will find the Lmin and Lmax in an automated fashion. So I'm going to present one solution below. What we're going to do is find the percent growth of the last day, and this is for cumulative cases, and then we're going to use this percent growth to extrapolate some number of days into the future. We pick a low number that can be used as Lmin. We pick a high number that can be used as Lmax. So let's go ahead and see how this works. So first we're going to get these smoothed cases, and then we're going to find the percent difference from one day to the next. And this is just the tail of the curve, and we are using the second wave of cases in Australia. So you can see here that at the very end, we're looking at close to about 3.5% growth per day. It's much easier to see this data plotted. So we can see here that towards the end, and this is right at the last date is August 1st, cases are growing just about 3.5% from one day to the next. So what we can do is we can take this 3.5% and just assume that it will grow at this rate for another, say, 50 days or something like that to bound the high end. And maybe at the low end say, well, let's just assume, just so that we're not too aggressive here, that it'll grow for another 5 days with this rate and use that as the lower bound. So what we can do is we'll take the very last value, so this is the very last smooth value, and then we'll take the smooth percentage. We have to add 1 here, because it's given as a fraction, so 1.035. We're going to raise this to the 50th power. So this happens first, just like any kind of compounded interest rate. We're going to have this exponential growth of 3.5% for 50 days. We're going to multiply it by the very last smooth value. So this will give us an upper bound, so around 98,000 we could use with this procedure. Now here's a function that automates this task. It's going to take in the smooth data S. N1 will be the number of days for the lower bound. N2 will be the number of days for the upper bound. So what we're going to do is just the same thing we did up here. We're going to get the very last smooth value. We're going to get the last percentage, so that was 3.5%. For the Lmin, we will take that last percentage, so really this comes first, so we're going to raise it to N1, and then we're going to multiply it by the last value. For Lmax, we're going to take that last percentage and raise it to N2, which should be a larger number than N1, and multiply it by the last value. That's how we got this 98,000. There's a plus 1 here for the edge case of where the last value is 0. And then L0, this will be the initial guess. We'll just take the minimum between, or the midpoint between Lmin and Lmax. That's all this is doing. And this takes care of some edge cases if there's missing values for Lmin. Then it'll just pick 0 and 1 like that. So this function just automates the procedure, and it may not be the best procedure, but it is some automated procedure for getting those bounds, which are fairly difficult to get right. So let's go put this into action. So we'll return Lmin, Lmax, and then the initial guess, which is just going to be halfway between them. So for us, the Lmin for Australia is going to be 21,000, Lmax 98,000, and then the initial point will be right around 60,000. Now we can have one more function. So this just does, notice this is just getting the L limits, the left and right bound for L. Now we're going to use one more function that gets all of the parameters, and so it's going to take in the same inputs, S, N1, and N2. So the first thing it does is it gets those bounds for Lmin and Lmax. It also gets the initial L. And then here, we've already used these before, X naught, K, and V, and then also Smin and Smax, so the vertical parameter over here, the vertical increase shift over here. We just choose the midpoint for S naught. And then we create our bounds, and we create the initial values for all of our initial guesses for all the parameters, and then we return a tuple of the bounds and the initial guess. So that does that function. And so when we run this, we're going to get two items back. We will unpack them. So here are the bounds. Like here are the bounds, the lower and the upper bounds for L, X, X naught, K, V, and S, like this. And then here are the initial guesses. So this function, combined with the function above, will automate the procedure of getting the bounds for all the parameters, and it will get the initial guess.